This video talks about the capability index CPK. So as we know, the CP value does not measure the process performance in terms of the nominal or target value. So that means the CP value does not consider the shifting of the center of our process. So the other measure that considers this shifting effect is called CPK. So the enumerator in the CPK is the minimum of the two terms. So the first term is the differences between the upper specification limit and the center of your process. The second term is the differences between your center of the process and the lower specification limit. So you take the minimum of these two terms as your enumerator, and then the denominator is 3 sigma, which is half of the process capability. So here's the same keyway example, and I want you to determine the CPK value when the process center is 6.45. So now in our enumerator, the first term is the differences between the upper specification limit and our process center. So that is 6.50 minus the 6.45. And then the second term is this process center, the 6.45 minus the lower specification limit, 6.30. Okay, so this one gives us 0.05, right? This term is 0.05, and this term gives us 0.15. So we need to take the minimum of 0.05 and 0.15. So we take 0.05 here as our enumerator, and then our denominator is 3 times the sigma. So the 3 times the 0.030, right? This serves as our denominator, and therefore the CPK value computed in this case is 0.56. Now, for the second question, if the process center is shifted to a lower side, to the 6.38, what will be the CPK value? So now we need to re-establish these two terms, right? The first term is the upper specification limit, 6.50, minus the center, 6.38 in this case. And then the second term is this process center minus the lower specification limit, 6.30. The sigma is still the same. And then we pick the minimum of these two. So this one gives us 0.12, right? 0.12. And this one gives us 0.08. So we take the minimum of these two terms, which is 0.08 in our enumerator, and it computes that in this case the CPK value is 0.89. When the CPK value equals to 1, that means the process is producing product that conforms to the specifications, right? So your process capability is not exceeding the tolerance, right? And when the CPK is smaller than 1, that means the process is producing product that does not conform to specifications. So your process is shifted to one side, and therefore there is a tail that is outside the tolerance limit. And if the CPK is 0, that means the average is equal to one of the specification limit. So you have shifted your center to be at the USL or at the LSL. Then that will give us a 0 CPK. If the CPK is a negative number, that means the average is shifted outside the specifications. Here are some comments about the CPK and CP values. So the CP values, as defined here, does not change as the process center changes. So even though your process center changes, your process capability does not change, right? The difference is the 6 sigma 0 is not changing. and therefore the CP value does not change. And if the process is centered, then these two terms are the same. So the differences between your control limits and the center of your process is the same as 3 sigma. And therefore, the CPK value and the CP value are equal. And this CPK value is always equal or less than the CP value. So I have derived this relationship. If the CPK is defined as this term, right? And if you doubled your enumerator and your denominator, then this is still equal, right? So now your enumerator is 2 times the minimum of these two terms, and then your denominator is 6 sigma. Now I use 2 times the minimum of these two terms. So this is the sum of the minimum of these two, right? And it must be smaller than or equal to the sum of these two terms, right? So one of these terms will be the minimum of these two, and then the other terms will be at least this much, right? So the other term will be greater than or equal to the minimum. So if you use the sum of these two, then it will be greater than or equal to the sum of the two of these minimums. And therefore, the sum of these two terms, the x bar will cancel out, and that will be the USL minus the LSL. So this is the definition for the CP value. And therefore, the CPK value is always equal to or less than the CP value. So here are the CPK and CP values for the 3 cases, for case 1, case 2, and case 3. And in 2 situations, when the process is centered and when the process is off-center with 1 sigma. So as we can see, the CP value does not change if you shift the process center, right? The CP value stay the same. However, when you shift 1 sigma, then your CPK value is going to decrease, right? Because the differences between the specification limit with the center of your process is decreasing when you shift, right? So like this one, when you shift, then the CPK value decreases. When you shift, this CPK value decreases. So here is some comparison of the CPK value and CP value in 3 cases.